So let us take first example. Examine for the consistency, and if consistent, then solve the following system of equations. We have given four equations. Equation number 1 is x plus y plus z equal to 6. The second equation is x minus y plus 2z equal to 5. Third equation is 3x plus y plus z equal to 8. And the fourth equation is 2x minus 2y plus 3z equal to 7. So even though we have three variables, but we have given the four equations, right? Let us go how to solve this system of linear equations. So we have to examine the consistency of the following system of equations. So now the given equations are this. So the system of simultaneous equation 1 can be written into the form of matrices. Like the coefficient matrix, we have to write down what is the coefficient of x, y, z. It is 1, 1, 1. And then the constant term is 6. Similarly, coefficient of x, y, z is 1, minus 1, and 2 in the second row. And the constant term is 5. And the third equation, the coefficients are 3, 1, and 1, like this. And the constant term is 8. And the fourth equation, the coefficients are 2, minus 2, 3, and the constant term is 7. So if we have given any system of linear equations, so that can be converted into the form of matrices Ax is equal to B. Now where A is what? A is 1, 1, 1, 1 minus 1, 2, 3, 1, 1, and 2 minus 3, 2 minus 2 minus 2, 3, which is called coefficient matrix. X, Y, Z is the variable matrix, and B is equal to 6, 5, 8, 7 is the constant matrix. Let us consider the augmented matrix. Augmented matrix is 1, 1, 1, 6, 1 minus 1, 2, 5, 3, 1, 1, 8, 2 minus 2, 3, 7. Now, if we want to check that the system is consistent or not, we have to find out the rank of a matrix A and rank of augmented matrix AB. If we are able to find out the rank of both the matrices, if the both rank are same, then we say that the system is consistent. Means the system has solution, and this solution may be either unique solution or it may be infinitely many solutions. So the question arises that, is it possible to find out the rank of coefficient matrix and rank of augmented matrix in one spot? So yes. Why? Because this augmented matrix AB contains the coefficient matrix as well as the whole augmented matrix. So instead of finding the rank of A separately and rank of augmented matrix, we will try to find out only the rank of augmented matrix. Means we have to reduce this matrix to its echelon form, and then we are able to say that what is the rank of coefficient matrix and also what is the rank of augmented matrix. Okay. So now how to reduce the above matrix to its equivalent form. So the first thing is how to reduce. So we have to ask the question that A1 is A111. If answer is yes, then we have to go to the second step. So now here, yes, A11 is 1. So with the help of these A11, we have to make this, and this 0 by only using the row operation. If you want to convert any matrix to its equivalent form, we have to only apply the row operations. We are not able to apply column operation. It is not permitted over here. So with the help of this one and these three operations, R2 minus R1, R3 minus 3R1, and R4 minus 2R1, we are able to reduce the above matrix into this form. Okay, let us check it. It's okay or not. So first thing, let me take the this R2 minus R1. So what is R2? 1 minus 1, 2 and 5. And R1 is 1, 1, 1 and 6. So let us subtract it. Minus, minus, minus and minus. So 1 minus 1 is 0. Minus 1 minus 1 is minus 2. 2 minus 1 is 1. And 5 minus 6 is minus 1. So just look here. 2 minus 1, 1 minus 1. Similarly, let us check about the R3 minus 3R1. So let me write down the third row, 3, 1, 1 and 8. Let us multiply this by 3. So this is 3, 3, 3 and 6 3s are 18. Let me again subtract it. So 3 minus 3 is 0. 1 minus 3 is minus 2. 1 minus 3 is minus 2. And 8 minus 18 is minus 10. So now we have the third row. Similarly, if we go to the fourth operation, R4 minus 2R1. So let's write down the R4. 2 minus 2, 3, 7. And what is, we have to multiply this by 2. So this will become 2, 2, 2 and 6 to the 12. Let me subtract it. Minus, minus, minus and minus. So this is 0. This is minus 4. 3 minus 2 is 1. 7 minus 12 is minus 5. So we have fourth row. So in this manner, we can apply the row operation and the matrix would be converted into this form. Now, let us repeat the same process into the second row. So let us go to the A22. We ask the question, is A22 1? So clearly it is not 1. So we ask another question, are all elements below A22 multiple of A22? So definitely here, minus 2 is the multiple of minus 2 and minus 4 is also multiple of minus 2. Then also we can apply the row operation. So with the help of these minus 2, we should make this 2 element 0 by applying the operation R3 minus R2 and R4 minus 4R2. So the matrix will be converted into this form. We can also check this one. Let me just check it. So what is the R3? It is 0. Let us first check R3 minus R2. So 0, minus 2, minus 2, and minus 10. Let us multiply, let us subtract it from the second row. Or second row we have to subtract from it. So 0, minus 2, 1, minus 1. Minus plus minus plus. So this is 0. This minus 2 plus 2 is 0. Minus 2 minus 1 is minus 3. And minus 10 plus 1 is minus 9. So we have 0, 0, minus 3, 9. Similarly, if we take about this operation, so what is the fourth row? It is 0, minus 4, 1 and minus 5. Let us multiply the second row by 2. So it will become 0, minus 4, 2 and minus 2. Let us subtract it. 0, minus plus, minus plus. So this is 0. Minus 4 plus 4 is 0. 1 minus 2 is minus 1. Minus 5 plus 2 is minus 3. So just look here. 0, 0, minus 1, minus 3. So next, let us apply the operation. Next operation, we have to now let us again repeat the same process. We go to A33. We ask the same question. Is A33 1? Definitely it is minus 3. So answer is no. The second question, are all elements below A33 are multiple of A33? So now it is A33 is minus 3 and minus 1 is not the multiple. It is the factor of minus 3. Okay. So now if we interchange the row 3 and row 4, then we get the positive answer of our second question. So that's why we are applying R13. So we get this row number 3 and 4 will be interchanged. So this -1 -3 and this -3 -4. Now we have the positive answer of the question. So now this is -1 and -3 is the multiple of -1. So let us multiply this by 3 and subtract it from the, oh sorry, uh, we have to multiply this by 3. So R4 minus R3 times of R3, then we are able to get the matrix should be reduced into the form of equivalent form. So there is no change in the first 3 rows. The last row will be -3 plus 3 will be 0 and -9 plus 9 will be 0. So now we have, this is called echelon form of the given matrix. So what is the echelon form of the given matrix? It is if we have given a matrix in which if all the elements below the main diagonal are 0, then this form is called echelon form of the given matrix. So now what was our first aim? Our first aim is to reduce the given matrix to its echelon form. Now the second thing is, now we want to find out the rank of its coefficient matrix as well as augmented matrix. So now suppose if you want to find out the rank of coefficient matrix. Now this is the coefficient matrix, this one only. So now if we see that how to get the rank of a matrix if that is converted into the echelon form. So we have to just count how many non-zero rows present in the given matrix. So the first one is what? The first one is this matrix is non-zero. This row is non-zero. This row is non-zero. This row is non-zero. But the last row is 0, 0, 0. So now how many non-zero rows present over here? Definitely 3. So the rank of coefficient matrix is 3. Similarly, if we go to the whole augmented matrix, so the first row is non-zero. Second row is also non-zero. Third row is also non-zero. And the fourth row is 0, 0, 0. So if we see what is the total number of non-zero rows in the augmented matrix, so we have also 3. So the rank of A, so this is called echelon form of the given matrix. Here, a rank of A augmented matrix is equal to number of non-zero rows. That is, rank of augmented matrix is 3. Also, rank of A or coefficient matrix is also 3. So since rank of augmented matrix is equal to rank of coefficient matrix, which is equal to 3, which is equal to number of variables, therefore, the given system of equation is consistent and have unique solution. So now, this is the answer of our first question. What was the question? That check whether the given system of equation is consistent or not. So we have checked that the given system of equation is consistent. And since rank of A, which is equal to rank of augmented matrix, which is equal to the number of variable, so that this system has unique solution. So now our second step is how to find the unique solution. So for that purpose, we take the equation number 3 and the equation number 1. Sorry, equation number 2 and equation number 3. So this is equation number 2 and this is equation number 3. So let us combine these two equations and let me write down the final matrix. So now this matrix is converted by this matrix. Constant matrix is converted by this matrix. So we have to just replace it. So 1, 1, 1, 1 minus 1, 2, and 3, 1, 1, 2, 3, 2 minus 2, 3. This is replaced by this matrix. Constant matrix is replaced by 6 minus 1 minus 3, 0. And the variable matrix is as usual. Now let us simplify or let us write into the form of equations. So first equation is 1 into x is x plus y plus z, which is equal to 6. The second equation is 0 into x, 0, minus 2y, and plus z equal to -1. And the third equation is minus z which is equal to -3. So now we have three equations, equation number 4, equation number 5, equation number 6. So from the equation number 6, this is very clear that z equal to, from equation number 6, we have z equal to 3. Now, if we substitute the value of z in equation number 5, so putting the value of z in equation number 5, we have -2y plus z equal to 3, which is equal to -1. So if we replace -2y, this 3 is replaced to this side. So -1 minus 3, which is equal to -4. Then this minus and minus will cancel. And the 2 will also cancel to y is equal to 4 by 2, which is equal to 2. So z equal to 3, y equal to 2. We obtain the two values of three variables. Now, means the values of y and z we obtain. Now substituting the value of y and z in equation number 4, we are able to get the value of the third variable, which is x. So x plus 2 plus 3 equal to 6. So if we replace this 2 and transpose this 2 and 3 to the right hand side, it is 6 minus 5, and so x is equal to 1. Hence, the solution of the given system of linear equations is given by x equal to 1, y equal to 2, and z is equal to 3. So, what is the conclusion of this question? So, the given system of linear equation, this system of linear equation is consistent and have unique solution, and that unique solution is nothing but x equal to 1, y equal to 2, and z equal to 3. Thank you, everyone.